we're going to now start looking at providing formula for given names. Our first name is lithium nitrate. We know that lithium is given by Li, and our nitrate is NO3. Now, to put those together, we need to make sure they're in the right ratio. If we look at our periodic table, we can see that lithium has an oxidation number of +1, and nitrate has -1. So we can put them just together in a 1-to-1 ratio like that. Next, we look at ammonium oxide. We know that ammonium is NH4, oxide obviously being oxygen. Ammonia has an oxidation number of +1, and oxygen has an oxidation number of +2. That means to balance this +1 and +2 out, we need to have 2 ammonium ions. Thirdly, we have iron 3 chloride. So we have iron, which is Fe. They tell us the oxidation number. We know that metals can have very different oxidation numbers for the same atom. They specifically tell us here that we have a +3 oxidation number for iron. Iron chloride, so chloride being chlorine or Cl, we know that that usually has a -1 oxidation number. So now to balance those out, we need to put 3 chlorines with that iron 3. Fourthly, magnesium sulfate. We know magnesium Mg, oxidation number of +2, and sulfate being SO4. We know SO4 has -2, so the ratios stay 1-to-1 as we see there. Lastly, potassium permanganate. We know that potassium or K has a +1 oxidation number, and permanganate MnO4 has a -1 oxidation number. Again, we can then say that this is in a 1-to-1 ratio. They now ask us to look at Lewis structures for a couple of substances. Firstly, phosphorus trichloride. So phosphorus, we know P. Tri means 3, so 3 chlorines. It's very important first to get the formula for this substance before you can start writing or drawing the Lewis structure. So we start off by putting phosphorus in the middle. We know that phosphorus has 5 valence electrons, so we draw those electrons around the phosphorus. 1, 2, 3, 4, and we'll add a 5th. You draw them one at a time and not 2 at a time, so that we can make sure they're evenly spread out. We then draw our chlorines around this phosphorus. And we know that chlorine has 7 valence electrons. One, 2, 3, 4, 5, 6, 7. We can see now, if we do this to the rest of our chlorines, that if these two electrons, and these two electrons are bonded, that both the chlorines and the phosphorus all follow the octet rule now. And we can say that this can happily be the Lewis structure of phosphorus trichloride. Lastly, the Lewis structure of carbon dioxide. We know carbon C dioxide, di meaning 2, so it's CO2, a substance that we should know a lot about. We start off with putting our carbon in the middle. We know that carbon has 1, 2, 3, 4 valence electrons. We now put our oxygens on either side. We know that oxygens have 6 valence electrons, so 1, 2, 3, 4, 5, 6. We can do this for both of our oxygens. We now see the obvious bonds between the carbon and the oxygen there. Our carbon has 2 leftover valence electrons, and our oxygens also each have 1. We can now join those into a second bond, like that, and like that. And we'll have carbon double bonded to oxygen on the one side, and again double bonded to oxygen on the left-hand side.